Okay, so we've been talking a lot about heat transfer. And so heat transfer, we've talked about how heat rises and cool air sinks. And so I'm going to conduct this little experiment. And so that's called the convection. Convection is when the warm air rises, cold air sinks. I've got a container with cold water, marked here cold. And I'm going to put a little food coloring in it so you can see that it will be, you can keep up with it. I think one drop might be enough. We'll see. Also, as I'm doing it, I want you to pay attention to how long it takes it to, for that blue food dye to disperse. All right, in this one is some hot water that I boiled this morning before I came to school. So this is going to be in this container, hot water. And so the hot water, and hopefully you can see that it's steaming. That condensation is building up from that hot to the cool. All right, and oh, I didn't quite have enough to fill it up, but that's okay. It'll still work. I think you'll see. And so now watch the red, one drop in that one. And you can see this one's moving a lot more because what did we learn about those molecules in the cold and the hot? The hot move a lot quicker than the cold. Cold molecules are condensed closer together. The red, which I was going to put another little one in there, but I don't even need to. You can see this one has already dispersed because when you're hot, you don't want anything around you. You want to spread out. So that's what these molecules do. They spread out. All right, so if, from what we've said about hot rises and cold air sinks, if I put this, even though I don't have it exactly, I'm going to flip it over. I'm going to put it on top of my bottle of cold. If I don't, I'm going to move these two because I may make a mess. When I flip it over, I'm going to put it on top of this. And based on what we've learned, the hot should stay on top of the cold and not mix as we would think that it would. So I'm going to go ahead and flip and put on top. And like I said, I probably would make a mess. And so I did a little bit. All right, so now I've got my little file index folder here. So I'm going to slip it out. All right, and so I'm still slipping it out. I got to line these things up. All right, there you go. So now, it's not mixing. It's staying. Warm air's up. Cold is down. Made a little bit of a mess, but that's okay. It's just water and food coloring. All right, so that shows. Now, what's going to happen over time? As over time, we're going to have that this is going to hot to cold. The heat transfer, the hot will move into the cold, and it will eventually get, everything wants to be equal, so room temperature, at which that hot and that cold will mix. All right. So there's your hot state on top. Warm air rises, cold air sinks. I'm now going to flip it over, and we're going to see what happens based on what we've learned. If hot air rises, cold air sinks. This time, the hot air is going to want to, the hot water, is going to want to move to the front top, and the cold is going to sink. So let's try this one time, and I am going to now flip, and they are starting to mix. So let's see what happens. Cold is sinking because cold wants to sink. And if you can somehow get closer to this, maybe I can move you closer. We'll try. You can actually see it moving in the bottle. This is about as close as I can get you. You can actually see the colors mixing. So remember, heat transfers, this represents convection, where the water flows. Hot air or hot water rises, cold sinks. Hot rises, cold sinks. Right now we've got a mixing of the two because the cold is sinking and the warm is rising. All right. Convection